Lesson 8.2 is about the Pythagorean theorem. The Pythagorean theorem is something you're already familiar with. It's that if you have, and it applies to any right triangle. If you take the length of the hypotenuse of any right triangle and square it, it is equal to the sum of the two side length squares. So if we call the side lengths A and B, and it really doesn't matter which leg you call A and which you call B, those are interchangeable, but the sum of the squares of those lengths will always be exactly equal to the square of the length of the hypotenuse. So in a nutshell, C squared equals A squared plus B squared. So to solve a simple leg length problem, I have a right triangle. The legs are of length x, x plus 2. The hypotenuse is of length 10. So to solve this, I can say that one leg squared plus the other leg squared. Keep in mind, when you have a binomial that's being squared, you want to wrap it in parentheses, and it needs to be FOILed out, that the sum of those two squares is equal to the hypotenuse squared of 10. So this is the a squared plus b squared equals c squared. So we get x squared plus, now let's remember, when I square a binomial, this means x plus 2 times x plus 2. It does not mean x squared plus 4. It means you have to FOIL it out. So x squared plus, we get, when we FOIL this, x squared plus 2x, so plus 4x, plus 2 times 2, so plus 4, is equal to 100. So I'm going to get this set equal to 0, subtract 100 from both sides. So combining like terms, I have 2x squared plus 4x, and then 4 minus 100, so minus 96, is equal to 0. Now, I can cut this down before I go and factor it by dividing both sides of this equation by 2. And when I divide the 0 by 2, it will still be a 0. So I'm really going to be factoring x squared plus 2x minus 48 equals 0. I'm going to continue this up here. So this is going to factor to two binomials, and it's going to be x plus 8 and x minus 6. So solutions are values that will make one of the binomials equal to 0. So either negative 8 or a positive 6. And we can see that x is actually a side length, and it cannot be a negative value. So the answer is 6, x equals 6. So that makes this leg 6, and this leg 6 plus 2, or 8. And that is a 6, 8, 10 right triangle, and you can check it because 6 squared plus 8 squared, which is 36 plus 64, equals 10 squared, or 100. And you'll learn that this is one of the better-known Pythagorean triples. Okay, for the second and last example, I have a hypotenuse of length 2x, one leg at x, one leg at 5 root 3. So let's start off with one leg squared plus the other leg squared. Again, wrap it in parentheses when you're squaring an expression like this, equals the hypotenuse squared. Again, wrap it in parentheses. So simplifying, I get x squared plus, now 5 root 3, when I square it, means 5 times 5 times root 3 times root 3. So you're going to get a 25, and then root 3 times root 3 is a 3. So this is going to be a 75. And then squaring the 2x squared, remember you get 2 times 2, which is a 4, 2 squared, which is a 4, and x squared, which is an x squared. So on that side we get a 4x squared. Okay, now I have two like terms in the x squared, so I'm going to subtract 1x squared from both sides. So I get 75 is equal to 3x squared. I want to isolate x, so first I need to isolate x squared, so I'm going to divide both sides by 3, and I'm going to switch the left and the right, which I can always do. So I'm going to have 1x squared is equal to 75 divided by 3, or 25. So technically, x is equal to the positive and negative square root of 25, or positive and a negative 5. Again, though, because x represents a side length, it cannot be a negative 5. So I just am simply have x equals 5 as a solution. So that would mean this side is 5, and this side is 10. So I have 5, 5 root 3, and 10. And that is it for Pythagorean theorem.